Hi, my name is Jim Young. I'd like to talk to you today about the NCL30051, which is a two-stage high power factor controller intended for LED applications. It consists of a critical conduction mode PFC and a resonant half-bridge controller in the same package. The feedback loop is closed around the output, and it goes back and modifies the control on the PFC, adjusting the voltage going into a fixed half-bridge converter. This is the 30051 demo board. It's set up to operate from 90 to 265 volts input. As built, the standard demo board provides 1 amp at 48 volts output, but it can be reconfigured to other voltage and current settings. The one nice thing about this demo unit is it has the ability for autonomous control. By that I mean we can put a motion sensor or a light sensor in with the demo board to change the level of the output power. This is important because in a lighting application, oftentimes there's no persons in the area, so you don't really need to be having the high dissipation when you just need a small amount of illumination for visibility. When someone walks into the area, the light can step up to a higher brightness, or depending on time of day or ambient light conditions. So right now this demo is hooked up to what's called a wall pack. This is an industrial lighting fixture that you may see on the outside of a building. Typically these fixtures are high intensity discharge lamps running usually from 50 to 150 watts input power. I've retrofitted this one to have LED as its main light driver. You can see on these strips here we have 16 LEDs configured. The driver is located externally to the light fixture simply so that we can show what the circuit looks like and feature our controller. Typically you would put that controller inside of the light fixture. So I'll turn this around so we don't blind everyone. We have it hooked up to an AC source and a watt meter. I'll go ahead and turn the power on, and you can see the light is illuminated, and we're drawing about 51.6 watts. After a short delay, the motion sensor becomes active, and it will step down the power whenever there's no movement. So we'll see if we've got it timed out here. You can see the power factor is up. Now it has dropped down to its low power setting. You can see we have about 8.9 watts of input. Power factor is still above 0.95. If we have any motion in the area, the lamp will step up to its high brightness, and you can see the power is back up to 51 watts. For demonstration purposes, the timer is set to a pretty short delay so that someone doesn't have to wait to see the effect of having no motion. So when the motion stops, the light drops down to a low level. Surprisingly, even at this 8.8 watt level, there's quite a bit of light being delivered out into the target area.